Hi everyone. We are looking at linear motion under uniform acceleration today. If you've got fundamental applied mathematics there, it's page 22. We're going to look at these three questions, 2, 7, and 12, but I'll put them up on the screen as well. So if you don't have the book, not the end of the world. First of all, linear motion means moving in a straight line. That's linear. Uniform acceleration means that the acceleration that your object, it's usually a car or a bicycle, is moving at doesn't change. It's always the same acceleration. And acceleration is how fast you're speeding up or how fast you're slowing down. So we're going to just learn by example, I suppose. A car, this is question 2, accelerates on a straight road with an acceleration of 3 meters per second per second. Okay, or 3 meters per second. It's speeding up by 3 meters per second with each second. From rest, so its initial speed is 0, and look for that phrase a lot, okay, because you'll often need to translate that into an initial speed of 0 to a speed of 24 meters per second. Find the time taken and the distance covered during this journey. Okay, so to approach uniform acceleration questions, we are going to use what's called UVAST equations, where we've got these 5 variables is what we work with. Initial velocity is u. We use v then for final velocity, a for acceleration, s is for something called displacement, which I'll talk about in a second, and t for time, so hence u vast. Velocity, acceleration, and displacement are all vector quantities. Now what that means is, as well as having size, they also have direction. Okay, so a velocity of 3 meters per second this way is not the same as a velocity of 3 meters per second in the opposite direction. Okay, so usually you'll say if that's positive 3 meters per second, you'll have to call this negative 3 meters per second. So we give these direction as well as size. Acceleration, how fast something is speeding up or slowing down. Displacement, so if I travel from here, displacement is your distance from your starting point. So if I travel 7 meters to here, that's a displacement of 7 meters. If I travel another 4 meters to here, that's 11 meters is my displacement. But if I then travel another 4 meters back, even though now I've done a total of 15 meters, my displacement is only 7 meters, my distance from my starting point. Okay, so that's the difference between displacement and distance. Here's one of the formulae we're going to use a lot in this chapter, but we normally rejig it. So you might know this from your junior cert. Acceleration is the change in velocity, okay, so the final minus the initial velocity, divided by the time taken. And I'm going to rejig that. I'm going to multiply through by t using just a little bit of algebra. Multiply both sides by t. You get at is v minus u. And then I'm going to take this minus u and move it over. It's going to become a plus u. So plus u plus at equals v. So v equals u plus at is one of 3 equations that we're going to use an awful lot. And the other 2 equations I'm going to give you now without motivation. So one of them is s is u2 plus a half at squared, and the other is v squared equals u squared plus 2as. These are on page 50 in your log tables, and you need to use these a lot. So learn these by heart, and probably on the inside cover of your copy, write those formulae in, because you're going to be looking for them quite a lot. So just so that you have them somewhere that's easy to access. I will do a separate video explaining where these formulae come from. But to come back over here with all of these questions, generally speaking, you'll start off by saying, well, what are my UVAST variables? So in this example, excuse me, initial velocity, well, it was from rest. That's an initial velocity of 0. Final velocity, 24 meters per second. Acceleration, 3 meters per second. Okay, find the time taken and the distance covered. Okay, so to find the time, what I'm going to do and what I'll always do is I'll say, well, in that case, I know u, v, and a, and I want t. So I'm covering up s there because I would need to say, well, which equation has those 4 variables? And there it is there, v equals u plus at. So I can fill in v equals u plus at. I can say, well, v is 24 equals 0 for u plus acceleration is 3, and I want to know what t is. So 24 equals 3 multiplied by t. Well, then t is 24 divided by 3. Okay, so 8 seconds is how long this journey takes. And you can see there, if you're comfortable with the algebra, and by the way, coming straight out of junior cert, you might not be super comfortable with the algebra, but you'll get there. And you can see that the time is 8 seconds. The distance covered, well, now that I know that that's 8 seconds, I can pick any equation I want. So distance covered, I'll just use this one here. That's displacement that they're asking after. So S equals ut plus a half at squared. That is going to be 0 multiplied by 8 plus a half of 3 is our acceleration. Our time now is 8 squared. So that's 0 plus 1.5, a half of 3 multiplied by 8 squared is 64. And what's that going to be? 3296 meters. Okay, so there's question 2. Similar type of question 7. So let's have a look at that one. A lift decelerates. Now what's different now is you're slowing down. So what that means is your acceleration is in the opposite direction to your movement. Okay, so when you do your UVAS this time, and you'll say my initial velocity was 3 meters per second. To rest, there's my final velocity, 0 meters per second. Find the deceleration in the last 6 meters, excuse me, of its motion. So 6 meters is the distance traveled. Find the deceleration and the time taken. Now, because this thing, if it's, let's say it's traveling upwards, starts at 3 meters per second, finishes at 0 meters per second. If it's traveling upwards and it's slowing down, then the acceleration is in this direction. It's actually slowing it down. Okay, so the acceleration is in the opposite direction, and for vector quantities, show that with a negative. So what we're going to find here is we get a negative answer for our acceleration, and then the time taken, we'll get a positive answer for. So coming back here, well, we know 3. We're initially not interested in time, so you have to pick the equation that doesn't have time in it. There it is there, and plug in all of your quantities. V squared equals u squared plus 2as. Now that becomes 0 squared equals 3 squared for u, plus twice the acceleration times 6. Okay, so that's 0 is 9 plus 12a. If I move that 9 over, I get negative 9 equals 12a. And then if I divide through, negative 9 over 12 equals a. Okay, so a, negative 9 over 12 has a common denominator of 3, so that's minus 3 over 4 and meters per second. Minus 3/4 of a meter per second, or minus 0.75 meters per second. Okay, I was going to do 12, but I think I'll leave it actually. I'll just finish this off. The time taken was the other thing they've asked for. Well, now that you know the acceleration is minus 0.75, time is an easy enough one. So you can pick any of them that you want to work with that has time in it, but this one is easier. This one, if you look, it's got time squared. You're going to get a quadratic equation. It's going to be a mess. So pick the easier one, v equals u plus at. Okay, v is 0. U is 3 minus, now acceleration is negative 0.75, so minus 0.75, don't forget that, times 2. Okay, we need to tidy that up to get t by itself. I'm going to move this over just so that I get a plus, and it makes my life a little bit easier. Plus 0.75 t equals 3. And then t is 3 divided by, okay, that's 0.75 multiplied by t. So you divide on the right-hand side. Divided by 0.75. And divided by 3/4, 3 divided by 3, that's going to be 4 seconds. Okay, I'm going to leave it there, and I'm going to ask you now, please, to have a look at questions 3 and question 4. Oh, there it is. Excuse me. On page 22, questions 3 and question 4, and we're going to carry on with 2A in our next class. All right, thank you.